Welcome to this new quick start guide for Cancha. Today we're going to be talking about the logs viewer. This is for viewing strip log data in Cancha. It's also where we principally look at metallurgical samples, where they're from, choosing samples we'd like to take, and analyzing multivariable information and sample properties. So let's get started. We're going to be using the Mount Wells Pine Creek data. I know nothing about this project. I found this data for free online at this address. Go ahead and I'll paste this in the show notes below. You'll be able to download this one from the Northern Territory government database. Let's have a little look to see what the data looks like. So we've got basically we've got an assays table, a collars table, a geology log table, and some surveys. If we look at that in the tables, you can see the collars have got the drill hole name, easting, northing, and RL. That's one that we use as normal. The surveys basically saying the dip and the azimuth, different depths. The assays table, they've got varying interval lengths, but most of them seem to be about 3 meters, 1 to 3 meters in length, and they've got these assayed for tin, tungsten, copper, and gold. So here we've got a geology table. This is more categorical information, where they've got lithology 1 and 2, alteration 1 and 2, mineralization 1 and 2, and then a color and some comments. So this is all imported in, and now we're going to be able to use this information in Cancha. So in 3D, what does it look like? This is what it looks like. We can see that first of all, let's have a little look at the assays. This is what the gold is, so not a huge amount. Just going to right click on the legend, show limits. Let's just bring that up using this button here. We can bring that up into the window here. We can see that there are some areas with 3 to 5 grams a ton, but most of it's less than 0.04 grams a ton. We can see that it's here. We could also in 3D, we could bring up, for example, the geology, and we could look to see lithologies. We could say, okay, the quartz maybe coincides with where that high grade gold was, just from memory. But using just 3D, we can't really tell, because we can only put on the lithology or the grades at a single time. We can't see them both at once. So this is why we would use the logs view. In the logs view, we can see for a single drill hole, in this case NWRC01, we can see lots of different numerical and categorical information side by side, and we can see whether there's something there that we can use for determining what the different ore types are. So let's talk a little bit more about this area. We've got, you still got the feature list here, so you can see your drilling and block model and metallurgical features here on the left. And you can pull any of these. You can pull drilling data, block model data, or metallurgical data here onto the logs view. Say, for example, we wanted to bring color in, we would just grab it here and then just pull it on, and bang, it appears. So this is from the geology table in blue. The feature's name is color, and this here is a bit of summary data. We can see that it's got 43 in this hole here. We've got 43% of others, 42% of DPRD, seems like deep red probably, and 7% of the orange category. It's come up with these numbers, like for example here, the tin value is this blue box that goes all around here. So this blue box is the entire hole just by default, and it says that we've got a minimum of 0% tin, a maximum of 0.57% tin, and an average of 0.05% tin. But we can see here that it varies the grade coming down. So what we can do is we can just click on any part of the graph and drag with our mouse down, and now we can see the blue box is a reduced size. It's now from 22 meters to 51 meters with an interval length of 29 meters. And this intercept has from 0 to 0.57% tin, but with an average of 0.1. Alternatively, what I can do is I can double click on this, and by double clicking on a single range, it'll select that whole range there, one solid run, in this case of a high grade tin. And here we've got a minimum of 0.03, maximum of 0.2, and an average of 0.13. The same works for categorical information. If I double click here on this run of grey wacky, it'll automatically select that grey wacky for us. Now, the quartz vein's quite thin. We can maybe double click if we're careful, but it's kind of thin. We can see it's just 1 meter. So what I can do here is I can hold down Control on the keyboard, and with the scroll button on the mouse, I just scroll in to zoom, and we can make it bigger. We can see better what's going on here. So here we can see we've got a quartz mineralization, we've got a high grade gold, 0.19 grams a ton gold, and that's that interval there. We just hold Control again and zoom back out, and it'll bring it back down. And of course we can take off, hand off Control, and we can scroll up and down. What we don't have here is a way to scroll left and right. So if, for example, we would have put a whole bunch of columns on here, then they would go out to the right of the screen, and you wouldn't be able to see them. So, you're kind of limited to how many columns you can fit on your screen. On the left, there's always this depth one. Now, it says depth in meters, but it's really agnostic to the units of measure. If your data is in feet, then it would be in feet, but it would still say depth in meters. So basically, this is the depth here. Numerical information is presented like this, and it's given a scale. It's a scale that Cancha gives it a pretty good scale, something that's usually pretty good to look at. It crops the highest values, so you don't get to see, in this case, anything over 0.08. And if we look at the tin in the assays, we can see that there are values up to as high as 10% or 12% tin. But if we were to put the scale here up at 10 or 12% of the maximum, then you wouldn't be able to see any detail in the rest of it. So what we do is we just use statistics to crop that at a reasonable point, and then you see a maximum. In this case, the algorithm decided that 0.08 was the best maximum to give you the best visibility. So things that are over that 0.08 obviously are not represented; they're clipped. But you can tell by the color, because the colors that are used here in the strip logs are the colors that are presented to us from the feature color ranges. So we can, just by right clicking here on the feature list, and we can bring up the features colors, we can see that we've got about 1,000 there, 1,900 and 700 in each range. And so sure, let's say for example I was to put this 0.08, we can see that of the close to 2,500 samples, 291 of them are over the 0.08. So that gives you an idea. You can change these, and by changing these, you'll see different colors on the thing. And also, obviously, if we do a change, might want to put this nice blue color here for tin. And when we go back to logs, now we'll see that it's this blue color, and the limits of the different colors has changed. Typically, this is why we would use, for example, let's look at a copy here, for example. So, you might want to set it up so that the lowest range, the weakest color, is at your cutoff grade, and that way you can sort of visually see on the logs very quickly, you know, where your cutoff grade is and where's a run with ore grade. So that's numerical information. Now let's look at categorical information. So basically it combines runs together, they've got the same label. And here you can see that there are gaps. This is gaps in the data presented in the tables. And yeah, basically all it does is here, it just adds up the runs by linear length. So when you know, if for example I was to select this this run here of deep red, you can see that it's 100% deep red, 100% of the BM mineralogy, 100% of the pink hematite, I guess, alteration, 100% grey wacky with these grades here. But if, for example, I was to, you know, maybe select this alteration here, then I'd start to see, okay, oh, this is a bit different. We've got 59% of one color, 21 of another, 9% of another. You know, it's not perfect. You can't fit all the labels into this little space here, so we've just decided to give it as a percentage. And if you want to know what the detail is, then you can just zoom in and you can see there. Incidentally, if you did need to put numbers on a numerical scale, you can say show labels, okay? They're not going to show up when you've got them only, you know, like a small number of runs. But if you zoom in, as soon as the text will fit, it'll show you the numbers if you want them to. This isn't usually, you know, super interesting for, you know, for assays, because, you know, you could just select it and you can see it here from the average. But it is very useful for example, if you've got metallurgical data up there, then, you know, bond work index or something like that, you might want to put a numerical value and not just a bar chart. So that's why you can click on here and say clear, show labels. If you click up here and you say clear, boom, it'll just get rid of everything. And then you'll just have to go ahead and put it all back on there by double clicking on each column there, and then maybe going back to the geology and doing all this sort of stuff. So that'll get these all back again, right? So now we've got this populated again. We can print out a PDF. Now the PDF, we can either select all and print them all as just one big PDF, or we can just select the ones that have metallurgical samples. In this case, we don't have any in here. Let's do something about that. Let's say, okay, we want a metallurgical sample. So I've selected this range here. It's from 38 to 68 meters. It's got these grades, love it. Right click, save samples. Now it just takes a few seconds to update because it's doing quite a few calculations in the background, but bang, then it gives us MBS 001. What happened there? Why MBS? Well, basically, I already had a phase one. I've been playing with this file before, setting up for the demo. And so I've already got a phase one. This is a new session. Let's go for a phase two. This project's name is Mount Wells. So let's give it an M. B is for the second phase. A, B, C, D is phases 1, 2, 3, 4. S is for sample, and it's the first one, 001. Maybe I'll select another sample, another run here, and say save samples. It'll give us MBS 002. And right now you can see here I can go back and forth between these two. If I go to the drill holes viewer, I can see where the drill holes are here. So basically, this is the same view that we can see in 3D. Let's just go, take out the colors, make it a little easier to understand. And so now if we go to the drill holes view, you can see these are the drill holes. And I can just click in a drill hole from the list by name, and it'll show me that. Or I could search for one. I could say, show me hole 22. And there it is, hole 22. Or I can look down the bottom here. This is a top view. You can see that this is, if I just put those, I'm just going to put these collars back on again. And I guess you can see that these collars are the same as this one here, right? So these blue dots are the same as these blue collars here. So if I select this one, it selects this one. Select this one, select this one. So you can see that this is an easy way for you to get around the deposit. If you want to just go selecting different drill holes, you can just click here and it'll get you the drill hole there that you're looking for. Same thing works for the met samples. You can see right now we've only got met samples in one hole. Both of the met samples we've got are in this hole here. Alright, so that's how we've got the samples saved up. Now, if we go back to drill holes and we click on this button here, what this is saying is this is meant to be a little metallurgical plant with a chimney. But if you click on it, it's only going to show us drill holes that have metallurgical samples in them. So now if we go to print our PDF, we can say only select the blue ones with the metallurgical samples. So out of all those holes, out of the 34 holes, there's only 3. And we just go to export, and then it's going to give us a possibility of exporting a PDF with all that information on it. Now then, we can also see that when we choose these ones here, you can see it tells you the name of the drill hole, easting, northing, RL, azimuth and dip of the collar. So it's all there. So that's most of what we can talk about logs. I guess there's only one other thing that I'd like to walk you through, and that's ratios. So let's go to the feature tree, and just going to say on the assays one, just right click and say create a feature. Add ratio. Okay. You could also get to the same thing by going to features and create ratio here in features, right? But basically we want to know the ratio, for example, of tin, tungsten, and copper. Yeah, we want to have them in this order, and we only want to have this ratio when I'm just making this up as we go here. Let's only do this when let's say I'll do something that's going to make some sense. So when the what have we got here? 0.03 for the tin. Okay, fine. So we'll create a ratio of copper, tin, and tungsten. If I wanted, I could bring tungsten up to the top. But let's only do that when the tin is greater than or equal to, I've already forgotten what it was, 0.03 or something like that. Yeah? What's the name of this one going to be? Let's call this, I don't have to name it. You know what, I won't name it. If you wanted to name it, you could. I'll just show you what happens if you don't. Apply. It gives us a name, ratio. It's not very creative. Ratio tungsten copper tin. Yeah? But this is a new ratio that's been developed here. If we go back to the logs view, I can now click on that and it will give us these ratios. And you say, well, there's gaps. Yes, there's gaps because this is where the tin, let's just move this over here. So I grab it with my mouse and just drag it over to the tin. You can see where it's got low tin, less than 0.03, it's not doing the calculation. This is very useful for sequential copper, for example, where you've got low total copper grade. You don't want to see sequential copper data. So this is a very handy way of looking at data. So you can see in all these cases that the tin is the dominant element, and a bit of purple, which is the copper, and not so much. Well, just one that one little intercept there with very high grade tungsten here, so 0.95% tungsten. So you can see it sort of helps bring out the fact that in that one small intercept, you've got much higher tungsten than tin and copper. So this is a very useful way of looking at data here, using this ratios column. It becomes categorical information when you look at it this way, so it reports in the same way as that. So say we wanted to, for example, delete some stuff, we could just click on there like that on the X, or we can just select it and then hit delete on the keyboard. And if we want to rearrange it, then we can do that too. Just move that around, and we can rearrange the columns in that way. Well, you know, I think that's most of it. Welcome to logs in Cancha. It's a very useful tool in order to be able to you know, jump around your metallurgical samples quickly. See, you know, what the metallurgical samples were made of, where they're from, and be able to compare different geological, numerical, and categorical information next to each other. And you know, I'm sorry I don't have it here, but you know, I do have the lookups. So if for example, I wanted to apply information from the samples, I can do that here as well. What you'll see here is that you know, I'm saying that the gold in this case, gold has got an average of 0.45, but it's just a single value for that whole sample. And you can see here also 0.45 for that intercept. Basically, you know, it's saying that 88% quartz out of the material here that's been classified, so it's called the whole sample quartz. If we had other things here like test results, we could add those to the list. If we had things from the block model, we could do a block model to drill hole using the features thing here, where you've got block model to drill holes. We can click on that, and if we had a block model, then we could be able to transfer the block model information to the drill holes, and we'll be able to look at the block model and the strip logs as well. All right, well, that's enough for now. I hope you've enjoyed learning about the different ways of using logs in Cancha, and hope you watch our other videos too. Thanks.